So in the last class, we have seen XPath. So different options. How can we use XPath and how can we write our own XPath? All right. So today we'll see one more option in XPath, which is XPath Axes. So what is an XPath Axis? So by using XPath Axis, we can navigate throughout the DOM, like top to bottom and bottom to top, and we can find any element on the web page. Even though we don't have any attributes or if we don't have anything for this element, still we can locate an element by using a neighbor elements. So suppose there are some elements which are there in the neighbor for that particular element, and we can still locate the element. So for that, we can use XPath Axis. So before using it, let us see what are the different type of XPath accesses, like what are the options are available in XPath Axis and how to use those options. First, we need to understand the terminology. That is the most important. And once you understand, then we'll see how to use XPath Axis. So let me share a small document. So this is XPath document, a very detailed document, and most of them we've already discussed in the last class. I will share this document. You can just go through this types of XPath, absolute relative, all these things. So we already discussed all these options in the last class. You can go through the document. And now I directly jump to the XPath Axis. Yes. Okay, now this is the picture you need to understand. All right, so XPath basically works on DOM. DOM is nothing but what? Document Object Model. So when the DOM will be created, when you're browsing any web page, your browser will create the DOM. And all the elements will be representing in the form of hierarchy. Right, so this is representing a DOM actually, this particular picture. And we need to understand some terminology, like what is self node, what is parent, what is a child, what is following, what is sibling. So these are the terminologies we need to understand first. Okay, so if you understand this, we can easily use those options. Let me just try to understand this. So first thing, self. So what is self node? Okay, for example, you can take any node in the DOM. That is called self node. So wherever you are starting, from whichever node you are starting, that is called self node. Let us assume here's 6 is a self node. You can take any node as a self node because we need to start from particular element or particular node. So which is called self. So from the self alone, whichever is there here, this is called parent. This is called parent element of self because this is derived from this parent. This is a child tag of this one. So 4 is a parent element of 6. 4 is a parent of 6. And for this particular 6 element, 7, 9, 10. So these are all child elements. Okay, under this, whatever elements are there, these are called child elements. 7, 9, 10 are called child elements. This one, 7, 9, 10 are the child elements of 6. Parent and childs. Now, if I look at 1 here, 1 is an ancestor of 6th element. Okay, for example, 6 is a self element. For 6, 4 is a parent. For 4, 1 is a parent again. Right? 1 is a parent of 4. So from the 6th element, 1 is ancestor. Ancestor is nothing but what? Parent of parent. So for 6th, 4 is a parent. For 4, 1 is another parent. So for 6, 1 is a ancestor. Ancestor is nothing but a like grandfather, grandmother, right? So parent of parent is called ancestor. And 7, 9, 10 are the childs. And suppose if you have a 7 here, 7 is having another child, or let's say 9 is having another child, or 10 is having another child. So these are all called descendant nodes of 6. Means what? The parent of parent is called ancestor. The child of child is called descendant. Okay, that is a terminology. So self is a main node from where we are starting, and parent, child, ancestor, and then Descendant. So how many I understood now? 3, 4, 5. 3, 4, 5. Self node, parent, child, ancestor, and descendant. So from the self node, 4 is a parent. From the self node, 1 is an ancestor because parent of parent. And from sixth node, self node, 7, 9, 10 are the child nodes. And from 7, we have another node called 8. This is a child of child. That means for sixth, 8 is a descendant node. So these are the terminologies we need to understand. Now, what is sibling? For 4, suppose 6 is there. 6 is a self node, right? For 6, which one is a parent? 4 is a parent. And 5 and 11, these nodes are also having same parent. So 5 and 11 are called siblings. Siblings of 6, like brothers and sisters. Okay, siblings. So because 5 and 11 also comes under 4. 4 is the same parent. Whichever is parent for 6th element, for 5 and 11 also having same parent. So 5 and 11 are called sibling nodes. Sibling. Okay. But what is preceding sibling and following sibling? So whichever node comes before this, that's called preceding sibling. Whichever comes after this node, that's called following sibling. So these are all childs of one parent element. And again, whichever comes first, that is called preceding sibling. Whichever comes next, that is called following sibling. So we can take any node as a self. From that, we can get all these elements. Okay, from this we will get all the elements. So these are the terminologies first we need to understand. Okay, now let me ask you something here. You guys can tell me. Suppose I'm taking this 9 as a self node. 9 as a self node. For this 9, which one is a parent node? Just give a number. Which one is a parent of 9? 6 is a parent. Which one is ancestor? Which one is ancestor? Yes, 4 is an ancestor because parent of parent is called ancestor. And from the 9, which one are siblings? Siblings. 7 and 10. Very good. Now, which one is preceding sibling? Preceding sibling is 7. Following sibling is 10. Okay, perfect. So this is how we can simply identify the nodes. So you can take any node from this DOM, and that's called self node. From there, you can navigate anything. Okay, so you can see the navigation. From here, we are locating parent nodes, means we are navigating the top, and by using this element, we are navigating to bottom like this. And by using the locator, we can also navigate side by side. In all the directions in the DOM, we can navigate. All the directions in the DOM, we can navigate. Okay, so that is possible by using x-axis. Now, if I look at 2 is a self node. Let us assume 2 is a self node. And what is a parent of 2 here? Parent. 1 is a parent. What is a child node of 2? 3 is a child node. What are the siblings? Siblings. Sibling. Is there any sibling for 2? Siblings, I'm asking. There is one sibling. 4 is there, right? Because both are having same parent or not? Both are having same parent. So 4 is a one sibling, only one sibling. Again, 3 is a child node of 2. 3 is a child, okay? 4 is a one sibling. Which type of sibling? Preceding or following? Preceding or following? Yes. Because if you come here, that is called preceding. If you after come here, this is called following sibling. Okay. So now you understood easily. So it is very, very simple. If you know the DOM, we can find any type of element. If you take any node from self, from that you can locate any element on the web page. Okay. So for example, let us take 6 is a self node. Okay. And now I want to locate this one. And for fourth node, I don't have any attributes. Still, even though if you don't have any attributes for the 4, still we can locate this element from the self node. First, we need to write XPath for 6. From there, you can go to the fourth element by using parent keyword. And similarly, suppose I don't have any attributes for 5 or 11. I want to locate this element and this one. I don't have any attributes for them. But still, I can write an XPath for 6th element. From there, you can identify 5th one. From there, you can also locate it 11th element. Similarly, if you have a 6th element and I want to locate this ancestor element, but I don't have any attributes for this. Still, you can locate from here. You can write XPath for the 6. From there, you can directly go to ancestor. Okay, so that is a possibility which we have in XPath. Even though we don't have attributes for the element, you can find that element or you can locate the element by using any of the neighboring elements. And what are the neighboring elements? Neighboring elements can be parent, it can be child, or it can be siblings, it can be ancestor, or it can be descendant. Okay, is this clear, everyone? Terminology is most important. If you understand this terminology, you can easily use this in our XPath. Okay, now, so let us see some examples how to use these XPath axes to locate elements. Okay, let me close this. Right. So the first example, parent. We'll start from the parent. And here the screenshot is actually incorrect. I will correct it. Just hold on. Okay. See this example. I have this HTML. This is my HTML. And this is my self node. Let us assume this is my self node. There is an input tag. Actually, this is a simple login screen. So this is the input tag. This is input box actually. And from this, I want to locate parent element. From the, what is the parent of this input tag? Here, there are 3 here, form, div, and div. Which one is a parent in these 3 for this input tag? So actually, the for input tag, this is a parent. The first div is there, right? So that is a parent actually, but in the screenshot, it is given incorrectly. For now, just assume, okay? So this is the direct parent of input tag. So forget about this one and this one, okay? So forget about this one and this one. So let us assume this is a self node and this is the parent node, okay? Now my requirement is I want to locate this particular node or this particular element from this. Okay, I want to locate my this form element. I want to locate my form element from the input node. Right. So what we can do is we can write an XPath for this input node. Let us assume this is our XPath //input @ ID is username. And from that, we need to go to the top, bottom to top. So this is the parent element I want to locate. Simply what you can do is use something called parent keyword. Parent. And every XPath axis, we have to use something called, this is a symbol, colon, 2 colons we have to use. This is a part of the syntax. It can be parent or it can be a descendant, following, sibling, whatever. After completion of this keyword, we use this particular symbol. Okay, colon and colon. So parent, colon. So after this, which one is a parent? Form is a parent. So you can simply specify the tag name. That's it. And you don't need to write any attributes for this form tag. You simply say only attribute name, sorry, only tag name. So this is the XPath of what actually XPath of representing this input tag. From there, we are finding the form element. So what we can do, parent, colon, and form. That is a tag name we can specify. So this is an example of XPath. How to locate parent element. To locate a parent element, simply you can say slash parent : form. And another XPath, same thing. So this is XPath which is representing input tag and parent : If you don't want to specify the tag name, you can simply say star. Star is representing regular expression. So whichever is got parent available, that element will be captured. And sometimes, suppose even I don't want to use XPath axis like parent, simply you can say slash dot dot. So dot dot will go to parent. But this is won't prefer most of the times. You can go with this one or you can go with this one. Okay, so this XPath is uniquely identify this element because there is only one parent always. For one element, there will be always one parent or multiple parents. In DOM, always one element is having only one parent. There is no possibility of multiple parents. It is not like inheritance. Okay, so one element is having only one parent. So as soon as you say parent form, it will directly go to the parent tag and it will locate that element. Now, if I look at this, which one is a target element in this XPath? Which one is a target element we want to locate in this XPath? Target element is form, not in input. But we are starting from the input. So input is what? This is a self node. We are taking this as a self node. From there, we are directly getting the parent element form. So this screenshot is wrong actually. The actual parent of input is what? This is actual parent as per the screenshot. But I'm saying just ignore these two lines. So then it will go and get this element. So this is how we can use parent element. Parent. We can capture the parent element. We can locate the parent element from the child element. Now, let us see another example. Child element. Locating child element. Okay, so see this. Locating child element. And same kind of HTML, just observe here. And here we are taking this as a self node. This is our self node. Okay. This is our self node. For this particular, okay, sorry. Yeah, this is a self node. Green is representing the self node. Okay, so from this, I just want to locate child element. Now, can you tell me how many child elements are there for this element? How many childs are there? Two childs, right? One is input, other one is span. There are two childs are there under this. This is one and this is a two. There are two elements are there. Now, I want to locate this element first. This is my self element. Now I can write XPath like this, / div id equal to div username. And this is the actual element we have written XPath. From this, I want to locate child element, one of the child element. Simply you can use child keyword, child : and what is the tag name of this child input? Input is a tag name. So we can say input, that's it. So here we have located child element. We have located child element from the parent. In the previous example, we have located parent element from the child element. Now we have located child element from the parent element. So let us assume you don't have any attributes for this input tag. Still, you can locate this element by using parent element. So first we have to return XPath for this element and child of : input. So you can say input. Instead of input, I can say span. Then the second element will match. That is also child element, right? Second element will match. So we can also use child is a keyword from XPath Axes. Okay, so parent and child, two things we have completed so far. Now, let us see the next one. Grandchildren. What is the terminology we have used for grandchildren? Grandchildren. Yes, descendant. What is grandchildren? Suppose, okay, it is a self node. This is a parent. This is a child. So child is having another child. What? Child is having another child, which is called as what? Descendant. Right? Child of child is called descendant. And the parent of parent is called what? Ancestor. Ancestor and descendant. Okay, now we'll see them. Ancestor and dependent descendants. So locating grandchildren. See this example. So here again, I have two inputs. So let us take the form. This is a self node. Okay, from the self node, I want to locate a grandchild. So which one is a grandchild of this form? First, let us find the child element. What is the child element of form? Child element. This is the one. Right? So this is the one. This is the child element. So from form, div and div. These are the both the two child elements. But I want to consider the second one. Okay. From this is the child element. From the second div, input and span. These are the two child elements. Now tell me, for the form element, how many grandchildren are there? How many descendant elements are there? Two descendant elements, right? So input is one descendant, span is another descendant. So these are the grandchildren for form tag. Now I want to locate this grandchildren input tag from the form. Okay. Now input is what? And input is what? A descendant of form tag. Input is a descendant of form tag. Okay. So how can we write that? Descendant. So let's go to the bottom screen. So descendant. So from this element, from the form element, if you are locating input tag, we use something called what? Descendant, right? So descendant. Suppose from this input tag, if you are trying to locate form element, from the input tag, if you are locating form element, then which keyword we have to use? Ancestor. Okay. You understood the difference between descendant and ancestor. If you are trying to locate form element from the input tag, we have to use ancestor. From the form element, if you are trying to locate input element, because this is a descendant, we have to use something called descendant keyword, ancestor and descendant. Okay, now see the examples below. Locating ancestors for the known element. So this is the example just now we discussed. See this. So this is the input tag and this is the ancestor tag. So from this input tag, we are trying to locate this form element. Form is what? Ancestor of input tag. So how to write a locator now? First, we will write XPath for the input tag, input element. Ancestor is my tag name. Sorry, ancestor is axis, colon, form. Form is what? The tag name of ancestor. Tag name of grandparent. Okay. So this XPath will locate this particular form element. Okay, that XPath will locate form element. And same thing you can write like this. First we'll write an XPath for the input tag, then ancestor, colon, you can simply say star, because there will be only one ancestor. There is no possibility to have multiple ancestors. So parent and ancestor will always be unique. One parent will be there for any node and one ancestor will be there. Similarly, from the self node, you can have multiple childs. You can have multiple dependents also, descendants, but ancestor parent will be only one. Okay, remember this point. So we want to locate the ancestor element if you look at input is a self node, from there form is an ancestor element. So we'll write a XPath for this input tag slash ancestor of form. This is the right XPath, ancestor. Same thing we will reverse for descendant elements. So for the descendant elements, you can do like this. This is the example for descendant elements. So descendant is nothing but what? Child of child. So if I look at this, now we can consider this as a self node. From this, we want to locate input tag. Input is what? Descendant element of form. So you can write an XPath for the form. This XPath for the form. Descendant is my keyword. Colon, colon. Input is a tag name of the descendant element. Instead of input, if I say span here, then it will able to locate the second descendant element. That is a span element. Okay, so form is a self node. If I consider the form is a self node, for that input is a descendant element. So from here to here, top to bottom. So input tag we can find. And suppose if you don't want to use, if there are two input tags, then you have to pass index number. Okay, suppose here there is input. If you have another input tag, that is also descendant. Then here you can pass index. If it is the first input tag, if you want to locate, you can bracket in the put 1. If you want to locate second input element, in the bracket, you can put 2 like this. So by using index, we can get the element. Now, same thing, if you don't want to use any access, still I want to locate an element, then what you can do? First, you can write an XPath for the form element. From here, you need to directly jump to the input tag. I don't want to get this one and this one. So these two tags I want to eliminate. So simply you can say slash slash, because what is the meaning of slash slash in XPath? Slash slash will directly jump to the element or tag. So when I say slash slash input, between this form and input, is there, if there are any tags are available or if there are any nodes are available, they will ignore it. And from form to input, directly it will jump. That is the usage of slash here. If you don't want to use axis, you can also directly use slash. Simple, another example I'll tell you. You guys can tell me. I have A1. This is my parent, one node. And which is also having another node called A2, which is also having another called A3. And in this, there are 3 child elements, A31, A32, A34. Okay. Now, I want to locate A34. How to write an XPath? From here to here, I want to directly jump. From A1 to A34. I don't want to get this element. I don't want to get this one, this one, this one. I don't want to get any of this element. Directly from here to here, I want to jump. Simply what you can do, A slash A1 slash slash A34. This will slash slash will ignore all the elements which will come between the main element, root element, and target element. So that is a usage of slash slash. Okay. It can be single element or it can be multiple elements present in between the root element and the target element. All the elements will be ignored if I use slash slash. You got my point? So I'll give you another example. So we use this slash slash many places. Let me just show you one more example. Okay, so let's say I have one div tag. Inside this, another I have div tag. Inside this, another I have div tag. So this is another tag and this is another tag. Okay, now I want to locate this div tag from here. So how to write an XPath? From here, I need to navigate here. First, we need to go to this one, div tag. Slash, inside the div, this is a child element. So I can say div tag. Inside this, there are 3 div tags are there. I want to go to third div tag, third one. So what you can say slash div of 3. This is an XPath. This is the XPath because they have a 3 div tags. I no need to ignore anything. Directly you can specify index. Okay, if I don't specify index, then what will happen? From this div tag, it will match all three div tags because we say only div, right? If I don't specify index, then what will happen? It will give you the first div element by default. Okay, if I don't specify index here, this will give you the first element by default. That's how XPath works. Okay, so now, so let us try to understand the descendants. So descendant means what? Child of child, or you can say grandchild. So here, this is the XPath of form element, descendant, input. Input is what? Child of child. From the form, this div is a child actually. From the div, input is a child. So for the form, input is a grandchild. That is descendant element. And you can also directly say / input. First, it will go to the login form. And from here, directly it will go to input because we don't have any input tags in this block. Only there is one input tag is there. So you can directly go to input tag. This is called descendant. Ancestor and then descendant. Now, we'll see another one. Following. Following and preceding. Again, in the following, we have a following sibling, preceding sibling. Okay, first we'll see what is following and preceding. So what is the following elements? Following. Siblings we have understood. See, for example, if it is a self node, this is our self node. What are the siblings? So along with this self, brothers and sisters. These are all what? Siblings. These are all called siblings. Again, in the siblings, we have a following siblings. We have a preceding siblings. We have a following siblings. This is called following siblings. These are preceding siblings. Okay, so here we are talking about following nodes. Forget about siblings because following in the sense itself is following siblings. Okay, following siblings and preceding siblings. There are multiple things are here. Following and preceding. Following sibling and preceding siblings. Okay, now just with the example, we will try to understand this. This is my HTML. In the HTML, if I look at this, I consider this as my self node. Okay, this is my self node. From this element, let's say this is my form actually. In this particular form, there are three input boxes are there. So this is one input box, this another input box, this is another input box. One single form, there are three input boxes are there. So these three are what? Siblings only. These three are siblings. And if I look at here, this input tag, this is another input tag, this is another input tag. These are all following nodes. For this input tag, below this, whatever nodes comes here, these are all following nodes. And above this tag, whatever comes are, these are all preceding nodes. Okay, actually in the picture, I'm representing in horizontal way like this. Okay, but in the DOM, how we will see? You will see like this. Okay, all are children of one parent only. Okay, but these are all preceding and these are all following elements. Preceding and following. Preceding sibling and following sibling. Okay, when you see the DOM structure, the picture looks like this. But here in the representation, when I draw the picture, I'm just representing like this. Because if you look at it in a horizontal way, you can easily understand. So these are all following and these are all preceding siblings. But in actual, in the DOM structure, this will come up and this will come at the bottom. Okay, so try to understand this. Now, so what are the following nodes of this particular element? So under this element, input is one following node, input, another input is one following node. If I look at the picture in the login form, it will be like this. So for this element, what are the following elements are there? This is one following element. This is also one following element. So these are the two following elements of this one. Okay. Now you guys can tell me. Same login form, 3 elements. Now I'm taking this as a self node. What are the preceding elements of this? This one and this one, right? These two are the preceding nodes. And if you look at the first one is a self node, bottom two are the following nodes. You understood now the difference between following and proceeding. Okay. Now, if you look at if you take first one is a first input box as a self element, bottom two are the following elements. Okay. And if you look at the bottom element as a self, and above two are the preceding elements. Got my point? So if you look at this, I'm taking the first input box. If I take the first input box, rest of the two input boxes are what? Following elements. Now, if you want to locate an element, this particular input box I want to locate. So I can write an XPath for the main input element. This is the first element. Name is what? ID is what? TXT username / following input. Now, which element it will locate in this? Because there are two inputs are there. As a following, there are two input box are there. Now, which input it will locate? The first input box. And if you want to locate the second input box, second following element, then what we can do? We can write index. Okay. So from the self node, we are locating following nodes by using following keyword. Okay. For example, I don't want to specify a tag name, just like I put a star here. So then what will happen? So star. So this will match both the input tags because we are not specifying index also. We simply say star, star representing all the tags, following tags in this element. Okay, that's the reason we can put like this. And as I said, if you want to locate a specific input box, we pass an index like this. Or we can also use index XPath function called last. First and last. Two methods are there. So you can put input. Inside the input, there are two inputs are there. Again, I want to locate the first input. So I can put first method. First function you can use inside the bracket. Or if you want to look at the last input box I want to capture, you can use last function. First and last. You can use these functions also instead of index. Not only input, you can use first and last functions in any example. So for example, here, this is my main div tag. Here, one div, another div, another div. Let's say I have 5 div tags are there. Now I want to locate this one. How to write an XPath for this? Div of / div of. Here you can pass index number. This is one approach. Another approach is what? Div of div last. We can call this method. So this will also get the last one. And if you say first here, then it will get the first div tag. And if you want to get middle div tags, you have to specify the index. So this is another way to point a specific element by using index or by using first and last. So these are the methods are available. So this is all about following. Following means what? From that element, whichever elements are following under this, they are all following elements. Means they are all having same parent. Okay. So if I look at this, next example, preceding. Locating preceding element. So exactly opposite of following. Star means it will match all the input, all the elements. By using star, we cannot locate specific web element. And whichever elements are there with that tag name, all the elements will be captured. Yes. So now preceding is exactly opposite of this. If you look at the preceding, now I'm taking this as a self node. Span is a self node. From this span, input is one preceding. This is also another preceding. So two precedings are there. For this span tag, there are two preceding, because this is a login screen actually. So this is my first input box, this is second input box. First input is presenting first element, second input is presenting second element. What is this span here is the label. You can see label here, right? So this label. So for this is a preceding element and this is also preceding element. If you want to get the preceding element, first you can write a XPath for the self node. I'm starting from span here and preceding : input. So if I look at here, preceding : input, there are two inputs are there. Which element it will match? Which one it will match? Obviously the first one, because we are not specifying index. If I don't specify any index here, the first input box will be matched. Second input box, if you want to get, how can we get? You can pass 2 index number, you can pass. So preceding means what? If you look at this, this is a self node. Above this element, whatever is comes under following. Okay, sorry, precedings. And bottom of this, whatever comes under following nodes. So following, and these are all precedings. Above all elements comes under precedings. Below all elements comes under following. Preceding and following. Okay, now we'll see some more options. Following sibling and preceding sibling. So we understood following, preceding, following and preceding. Now following sibling, preceding sibling. So what we need to understand here is, this is a self node. Okay. So these are all what? These are all, which one following, which one is preceding here? What is this part? Proceeding or following? Following, right? So these are all following elements. These are all preceding elements. And what is these actually? These are all the same, having same parent. So that's the reason we call them as siblings. Okay, in the siblings, again, following and preceding. So these things should be siblings first. Inside the siblings, we will find following siblings and preceding siblings. And one more important thing. What is the difference between only following sibling? Both are different actually. Following and following sibling is one category. And preceding and preceding sibling, only sibling, sorry. Preceding sibling, only proceeding is different. So what is the difference is, sometimes what happens is, if you look at the self node, following is nothing but what? All kinds of element. Under this, whatever elements comes under, all elements will be captured. Only preceding means under this, all preceding elements will be captured. So after these elements, self node comes, and after self node, following nodes comes. And these elements may not be may not be siblings. May or may not be siblings. Remember that point. I'm talking about only following and only preceding. When I say only following preceding, there may not be siblings. Without siblings also, following preceding elements will be there. So when I say following, under that following, there may be child elements, there may be grandchild elements, parent elements, all elements comes into picture. So following means they may not be preceding, they may not be siblings. Even though they have not siblings, still we can capture following elements. Okay, same parent element. Okay, so only following, only proceeding, if you look at following and preceding, these elements may or may not be siblings. That's the point I want to convey. So earlier, what we have understood is just following and preceding elements. We haven't noticed about siblings, only following and proceedings. Now, following sibling, preceding siblings means only in the siblings we are finding following and preceding. Only in the siblings. But in the previous example, we are not considering siblings. We are considering all the elements. So following elements, preceding elements are different. And if I look at only following sibling and preceding sibling, they are should be siblings first. Inside the siblings, we will find following and the preceding. And if I look at this example, okay, our target element is what here is span is my target element. And input and span, what is the parent of these two tags? And this one, this is a parent. So obviously these two are siblings. These two are the siblings. So if you look at, sorry. So if you look at this, 1 second. Yeah. If you look at these two elements, if you consider span element as a self, input is what? Input is what? Sibling only, right? For input, span is also sibling. So which type of sibling is it is for span? Which type of sibling it is sibling? It is preceding sibling, because this comes before the span. And when you consider input is a self node, what type of sibling it is? Span, following or preceding? Following sibling. Okay, because it will come bottom of this input. So for input tag, span is a following sibling. For span tag, input is a preceding sibling, but both are siblings. So that is a condition. You got my point? So now if you write an XPath for the username, this XPath for the input tag, following sibling, span. That means what? We are locating this following sibling from the input tag. So this is the XPath, complete XPath. And if you put star also, it will be able to match, because there is only one sibling is there for this input box. So obviously it will go and directly locate span element. This is called following sibling. Following sibling. Now exactly opposite of this. Preceding sibling. Preceding sibling. Same example again. This is preceding sibling. If I look at this again. Now I want to locate my span tag from the input tag. So input is what? Sibling only. So we will write, sorry, from bottom to top. So we'll write an XPath for the span tag. From there, we will locate the element. Now this is becomes a preceding sibling, right? So this is the XPath of the span tag. Span contains a text username / preceding sibling. This is a keyword. Preceding sibling of what? Input is a preceding sibling. And because there is only one input tag here, we can simply say star. Star also representing specific input box. So like this, we can use preceding sibling. So how many we have covered so far? Let me just write down everything. So we understood what is self element, right? Self. Whichever element we are starting, that's called self element. Now we understood what is parent element, child element, ancestor element, descendant element, right? Following element, preceding element, following sibling, preceding sibling. Right? Is there any other options covered so far? No, right? These are the options. Self, parent, child, ancestor, descendant, following, preceding, following sibling, preceding sibling. So these are all comes under XPath Axes. Okay, and these are all different XPaths. Example, these we already discussed actually. So chained XPath we have understood, right? So this is the example. So this is the XPath and / and this is another XPath. Chained XPath. XPath followed by another XPath. And yeah, so this is all about XPath Axes. This is full-fledged document for XPath, and you can find all the even last class whatever we discussed, even those examples also available in the types of XPath, absolute XPath, relative XPath. Okay, and then this sample HTML code of login screen, and different examples, locating elements with the tag name and attribute, locating elements with the static visible text. That is called inner text. Static visible text means inner text. So this is inner text. And locating elements when part of the visible text is static, like contains method we discussed, contains and text method. Okay, I will share this PDF. You can go through each and everything. So locating elements when prefix of the inner text is static means start with function. In the last class we discussed start with. So locating elements with visible text in input elements like this, tag name, value. So by using attribute we can locate element. Locating elements with multiple attributes. This is also we have seen. Multiple attributes means we can put one attribute, two attribute. You can put n number of attributes. You can use AND operator. Okay, and you can use OR operator in XPath. Locating elements with the dynamic attributes means we can use either contains and start with, we can write a dynamic XPath. And this is the XPath Axes. Okay. Now everything we can make it simple in SelectorsHub. So in SelectorsHub, there are more features are there. Let's say google.com. And here, let me open the browser. So you can just look at if you install latest version of SelectorsHub, you can find this icon. You can just click on it. So you will see window like this. Okay. And even if you open another tab, another applications like this window is still open. Okay. This window will not be closed. So this is a new feature they have introduced in SelectorsHub. But in the previously, how we have done is, if we open one page here, if you right click and inspect SelectorsHub will open in here. You can see in the dev tools, you can see the SelectorsHub. But if you, as soon as you open another tab, that is disappear. So you cannot see. Again, you have to right click and inspect, and again you need to open the SelectorsHub. One more time you need to go and open the SelectorsHub. For every page, you have to open the SelectorsHub. Right. So that is a problem earlier. So now what we can do is you can simply click on this icon and you can see SelectorsHub. And as even if you open another tab or any other applications, still it is open here. So this is another useful feature. You can just maximize and minimize and everything. You can do it. And some more important options are there. If I locate any element, for example, here I'm locating, inspecting this element. And even you don't need to use the DevTools inspect option. Directly they provided one inspect option in the SelectorsHub. Click on it and then inspect this element. Okay, so you can just click on it and then inspect this element. Okay, now if you select this black, now it is got selected. Takes few seconds of time. Okay, sometimes if it is not working, directly go with this DevTools. You can inspect any element. You can just right click on this element like this, inspect. Okay, this is the input element. So you can just look at any element. You can just inspect. As soon as you selected this in SelectorsHub, it will automatically generate all the locators. So let me open another page. Okay, so you can take any page like this and you can just explore. I will show you some more options in SelectorsHub. Right click and just open the SelectorsHub and you will see this. Yeah, now you can see I just inspected this and you can highlight any element on this particular page. So for example, I'm highlighting search box here. Now we can see it is given all types of locators automatically. Relative CSS selector, relative XPath. And all the locators, we don't use Selenium because they are giving locators for all other tools also. And we use absolute XPath, class name, name, and relative XPath. Okay, so all these things we can give. So if you want to use any access, right? So how can we do it? Suppose I'm locating the search element, this XPath for what? Search element. So you can simply say // So this is a one, sorry. Okay, this is a one element is matching. And if you simply say here // it will show you all the options. Suppose I want to get all the following elements. You can see as soon as you type F4, it is showing three options, following sibling. If you want to get all following elements, you can select this one, following elements. And again, in the following elements, there are n number of elements are there. So you can simply say star here. Now observe 313 elements are there. These are all following elements of the search element. As I said in the beginning, following and preceding elements may not be siblings. They may not be siblings. So all elements we got, but only we want following siblings. Okay. So then what you can see here, instead of following, you can simply say following sibling. So automatically all auto suggestions will come. So following siblings, you can say star. Just observe, there is only one element is there. Following sibling. Only one element. What is that? This is search element. This is the following sibling. And suppose I want to get preceding sibling. And only precedings. Only precedings. So I can write like this. // I can say following. So we are not getting preceding because we don't have any preceding elements for this. Okay, so following. And suppose I want to get child elements. Let's see. Do we have child? No. And do we have a parent elements? Yeah, parent elements are there. So let me take parent and then star. See, only one element, because always parent will be only one element. And do we have a child elements for this? You can say child. Let us try. No. If it is not giving any auto suggestions, means there is no elements for child. Okay, that's the meaning of this. And what else? You can try. You can take any element as a self node and you can explore all these things. You can check parent elements are there or not, child, ancestor, descendant. Let us see ancestor element is there or not. Yeah, ancestor elements are there. You can just select the, see here, ancestor, when I say star, 7 elements are there. So ancestors, 7 elements are there. Because I put star here, right? So ancestors are there. Right? So like this, you can find. In ancestor, again, if you want to locate a specific element, we can locate. You can say ancestor header. This will give you only one part. In ancestor, there is one header. And similarly, we can also get descendants. You can say type D. So if you're not getting, there are no descendants. Okay, so like this, you can just explore all XPath Axes inside this SelectorsHub. Okay, and we can also use another features. So you can see these are, I will explain these features in the coming sessions. XPath healing, form page, code, attribute, because once you understand some more concepts like a page object model, that time I will explain, okay, what are these options and everything. Even debugger, code, very useful options are there, so which will reduce a lot of time and effort while creating our locators. Very, very helpful. So I will explain those topics in the coming sessions. And yeah, so you can just say inspect, and you can also see the SelectorsHub in the DevTools window. And here you can see all the options it will show you. And same features are available here also. In the side right side, you can see this is driver command. So currently locators are generating like this, right? But I want to generate this along with the command, like driver.find element. So then you can choose this option. Second one, set driver command to append on selector. When just click on it, automatically the XPath syntax will appear, and now you can see all XPaths, all locators will be generated along with the command driver.find element by.xpath. So from now onwards, and if you are trying to locate any element, suppose I'm locating this logo element. Now you can see it is generated logo element locator along with the driver.find element. So this is one of the important features. A driver command is available. And this is for generating locators page. Suppose sometimes you want to get the locators for multiple elements. Okay, for example, I want to generate a locator for open cart, search, and multiple elements. Then you can use this option. So just click on this circle, click generate locators page and multiple selector. You can just click on it, and that's it. It will open one window like this. And whichever element you want to generate the locators, you can just show them. That's it. You can just locate this open cart element. See here. And as soon as you just click on that element, it is automatically generate the locator. See here in this box, whichever element you selected from this page, it is generating all the locators directly like this. List of locators, you can copy paste. So here CSS will be generated, XPath will be generated, and ID, if available, IDs will be generated. If name is available, names also will be generated. You can simply copy this. Copy all XPath and you can use it in your automation. So these features will very useful when you're designing the frameworks actually. Okay, so at that time I will again explain all other features. So this is for debugger, maintenance, and multiple options are there. Okay, and sometimes you can do like this. For example, locate one of this element. See, I'm locating this search element again. I don't want to use this driver command. So let us, this is the XPath, right? And by default in XPath, if I look at here, attribute value put inside the single quotes, right? It is putting in the single quotes. And whichever element you locate on this page, XPath will be generated, and the attribute value they keep inside the double quote, single quote. So you can directly use this in your by.driver command. Driver.find element by.xpath command, you can use it. Suppose I want to generate the double quotes instead of single quotes. Simply what you can do is you can use this option. Click to generate selectors with a double quote. And once you selected this, from now onwards, all the locators attributes, they will keep inside the double quotes. Suppose I'm locating this element. See here, the attribute title value put inside the double quotations. So you can put either single or double quotations, both are correct. But when I use this in your automation script, put inside the single quotations. And again, if you want to remove these double quotations, again, one more time, click on this. And now onwards, everything will be in the single quotations. So like this, there are some more features are there. In the next session, I will discuss more about this. Not in next session, once you start our framework concept, there we will generate page object classes. So that time I will explore all the features, but in the middle of the session somewhere, I will show you this debugger option. Okay, and smart maintenance. And there are some more options are there. So I will show you that. SelectorHub is available in all the companies. Many companies, very big companies are using it. I don't have any issues with this. You can still use it, no problem. Right, so I will give you one example for this Ancestor. You guys can try. So by using XPath Axes, just a second. Let me create another package. So new package. Today is day 25. Okay, so I'm just creating a new class. Name it as XPath Axes demo. So I already have an example which I already created. I will provide you that. You can just explore. It's very simple. So XPath Axes demo. So this is the example, guys. So this is the web page I have taken. So in this, you can find all kinds of elements, following siblings, preceding, ancestor, childs, everything. So this is simple tabular format. So these are the elements actually. So in this, I have explored all kinds of XPath Axes, self element, how to use self, and how to use parent, okay, how to use ancestor, and how to use ancestor along with the descendant, ancestor along with the following. At first, you can go to ancestor. From there, you can get the preceding. Okay, and then go to ancestor. Then from there, following sibling, and go to ancestor. Then following preceding sibling. So these are the different examples I have taken. Let me try to execute. You can find all the combinations of elements in the table. No such element exception. LNT self A. So I'm taking this LNT as a self element because this page keeps changing. This is more dynamic. So LNT is not there in this list. You can take any other element. So let me take, you can take anything. Let me take this Zomato. So Zomato. So LNT is not there in that list. So all LNT you can replace with a Zomato. Say Control F and all LNT I will replace with a Zomato. You can take any of the company which is there in this table. So now I have repeated everything. So all LNTs I have repeated with the Zomato. Okay, let's execute now. I'm considering one LNT is a Zomato is a self node. From there, I'm getting all other nodes, neighboring nodes. Yeah, now we can see these are the different nodes we got. So self is Zomato, even parent is also Zomato is available. Let me check. Where is a parent? I think for the parent also same name is given. So it is giving Zomato. Number of child elements, ancestor element, number of descendant nodes. I'm just printing size actually. I'm not printing all the elements. I'm just printing the size. So number of following elements, 117, preceding nodes, 49, following siblings, 115, preceding sibling nodes, 48. So you can capture that information. So this is example. I will also give you the video link on this. I have clearly explained this example. You can just go through it. Just a second. And also, if you want to learn in detail SelectorHub, recently I have created some videos on my YouTube. Playlist is available. In the free time, you can just go through this. So this is for XPath Axes. So this is the link, and this is for SelectorHub tools. In the SelectorHub, there are many options are there. All the tools I have explained in the playlist. So you can go. Anyway, in the coming sessions, I will explain about SelectorHub. But if you want to learn in detail all the tools from SelectorHub, you can go through playlist. And this is example I have explained in the first link in detail. Okay, take this. And self node, it keeps changing actually. So here today we have taken Zomato, right? So tomorrow, because these companies are from the stock market list, right? So this keeps changing. So on particular day, whenever you're trying this example, you can just check and what are the companies are there in the group A. You can take any company from this list and that you can replace here. So everywhere, copy and replace. This will work. Okay, these are very advanced locators. Okay, and it is not mandatory use XPath Axes. Even though if you do not use XPath Axes, still we can manage with the normal XPath functions. So whatever we so far we covered in the last classes, like what is XPath, relative XPath, chained XPaths, XPath with start with, XPath with contains, XPath with text, and then or operator, end operator. So with this we can manage. Even though if you are working a very big project, still it is fine. They are more than enough. Okay. And if you are more familiar with the XPath Axes, then you can try it. Otherwise, no need. These are very advanced level of locators. And if you find any very complex pages, and if you're not finding any attributes for the elements, okay, and page is more dynamic, in those cases, you can prefer to use XPath Axes. Otherwise, you can still manage with the normal options which are already available with the XPath. So this is all about locators concept. Almost 3 sessions we discussed only on the locators part, because in automation 80%, 70 to 80% of the job is locating the elements. That is a major part. So once you locate an elements, because in a web page not only 1 or 2 pages, you will have n number of pages. So n number of elements are there for each page. So in automation projects, the day 1 task is what? You need to create a page object classes. You need to locate elements from different pages, and that will take a lot of time. So if you do manually everything, so it takes a lot of time. So SelectorsHub will help you to reduce the time and also effort. It will make your job very, very simple and very, very easy. So once you start our project, I will show you how to use SelectorsHub very effectively, especially while working with the locators concept. So 70% of the effort we will put in locators. So once you write all the locators, the next thing is we have to interact with the web elements, and we will perform different type of actions. We will perform different type of validations. Okay, then we will create an end-to-end test cases. So this is the basic concepts. Once you understand how to locate element, how many ways we can locate an element, the next step is we will learn different type of commands from WebDriver to perform different actions on web elements, to automating the test case, to perform the validations. So that is the next thing. So from tomorrow, we will see how can we interact with the different type of elements, how can we validate them, like how can we handle input boxes, what type of validations we can do input boxes, and how to handle checkboxes, radio buttons, drop downs, images, links, tables, okay, and mouse operations. How can we perform drag and drop, how to perform double click, how to perform single click. So these are all different type of actions we perform on the web elements. So next few sessions, almost 5 to 6 sessions, we will deal with the different type of web elements and different type of action methods we will learn along with the locators. Locators concept will continue. On every day, on every example, we will use a different type of locators. So after a few days, you will be familiar with all kinds of XPath functions, options, everything. You don't need to separately practice them, because on day-to-day basis, we are trying to use everything in our automation test scripts. After 2 days, you will be familiar with all the options in locators as well as all the commands from the WebDriver. You don't need to separately practice them. So just practice my class examples, whatever assignments I'm giving you, just practice them. So you will be familiar with everything in few days. Okay. So that is the next plan. So we will continue in the tomorrow session.